All right, so just continuing on with trig, here's a little review of what we did last week. So if you haven't grabbed your unit circle, go ahead, when you pause the video, go grab your unit circle to help you figure these out. We will go through them together, and just remember that tangent of theta is y over x. So those x, y values around your unit circle can help you figure out what tangent is. All right, so hopefully you had a chance to try at least some of them out. Maybe you didn't do all of them, but I'm going to get my handy dandy unit circle out. And so tangent of pi over 3 is going to be, and we're just going to do one, and then I'll go through and show you the others. Tangent of pi over 3, I should have put pi over 3 there, is root 3 over 2 divided by 1/2. And so remember, when you divide fractions, you take the reciprocal of the bottom and multiply. So those cancel out and we get just root 3. So for tangent of pi over 3, you should have got just root 3. If we go to tangent of 2 pi over 3, we're over here. You can see that the value is going to be the same as the just root 3, except for it will be negative. So negative root 3. If we do tangent of 4 pi over 3, so now we're down here in quadrant 3, it's going to be positive again because they're both negative. So this is positive root 3. And then if we come back over here at 5 pi over 3, we can see that we have one negative again, so negative root 3. So maybe you're starting to see a pattern here on the tangents. All the same value, it just depends on what quadrant they're in and what you would get for tangent. All right, so now we're going to look at 7 pi over 3. You might be saying, well, Mrs. Ice, I've looked at my whole unit circle and I do not see 7 pi over 3. Well, I will tell you something, that 6 pi over 3 is really 2 pi, right? So I went around more than once. So I went around, this is a whole 6 pi over 3, and then if I wanted to go 7 pi over 3, I'm back up here. So I'm back to where I got a positive root 3. Now if I go to F, I want to do a negative pi over 3. That means I went clockwise, so I'm down here. So this is where I got a negative root 3. And if I want to go a negative 4 pi over 3, here's 1 pi over 3, 2 pi over 3, 3 pi over 3, and 4 pi over 3. So I'm up here at in my second quadrant. So that would give me a negative root 3. And then if I wanted to do the negative 10 pi over 3, so remember, we're going around clockwise, so this is a negative 6 pi over 3. Then we have 7 pi over 3, 8 pi over 3, 9 pi over 3. Oh, look, we're back here, 10 pi over 3, which is the same as 2 pi over 3. They're coterminal. And so I also have a negative root 3. All right. Let me know if you have any questions on that. But we are going to start going the inverse direction in this week's theme. So last week we went from taking an angle and getting a value. And so this week we're going to start working towards taking the value and figuring out what the angle is, which is really inverse of tangent or inverse of cosine and so on. All right. So quick review of unit circle. This is like geometry a long time ago. This is central circle. This is how you could find your radius if your circle had an origin of 0. But here's where we're at with our unit circle. Our radius of our circle is always 1. So we have x squared plus y squared equals 1. that might remind you of another equation, a squared plus b squared equals c squared. That's the Pythagorean theorem. So really this unit circle is related to our Pythagorean theorem of right triangles. And we're going to use that for today's lesson, or for task number 1's lesson. All right, so here's how we do it. Find a point on the unit circle given just part of your point. It says x equals negative 1/2 with xy in quadrant 2. So here's what we have. I'm going to draw a picture, and you certainly do not need to draw a picture for yourselves for homework, but I'm trying to teach the lesson. So it says we're in quadrant 2. So here's our quadrants. I'm over here in quadrant 2, and I can just draw my picture anywhere over here. And it says that x is negative 1/2 over here, but we don't know why. That's what we have. That's our picture we're trying to find. So how can we figure out what y is? Well, we kind of have a Pythagorean theorem. So I could plug in what I know for x is negative 1/2 squared. I don't know y, but my radius for this triangle is 1. So now I can just solve for y. So what's negative 1/2 squared? Well, it's going to be 8. Negative 1/2 times negative 1/2. That's a positive 1/4. So 1/4 plus y squared equals 1. Subtract 1/4 from both sides, I get y squared equals 3/4. Really try to keep it in fractions here. Do not turn it to decimals. And now when I take the square root, I get y equals plus or minus the square root of 3 over 2. Now I just need to figure out which it is. Is it plus or minus? Well, I'm in quadrant 2, and so what are my y values in quadrant 2? Well, they're always positive. So in this case, I'm going to say y equals my positive root 3 over 2. So if you need to take a moment and get all those notes down, go ahead and pause the video. All right, we have one last thing we want to do, and it's a little bit more involved, but it's using that same thought process, x squared plus y squared equals 1. And you're also going to want your unit circle on this, or, well, I'm just going to draw a picture, because these aren't values you see on the unit circle. Like the previous slide, you would see negative 1/2 on the unit circle, and you would just need to figure out what the y value was. So that's from a special right triangle, but this one's not. So first it says verify that it's on the unit circle. So your homework problems or task problems may not be on the unit circle. So how do you verify that? Well, you plug it into this equation here, and when you take negative 3/5 and you square it, and you take negative 4/5 and you square that, you are hoping it equals what number? Well, it should equal 1 if it's on the unit circle. So negative 3/5 squared is 9/25. And negative 4/5 squared is 16/25. And that equals 25/25. So yes, it's on the unit circle. So we figured out that it is on the unit circle. And now let's figure out how we can find 3 other points on the unit circle using symmetry. You guys know what that word symmetry means? It's like finding something else in a similar spot. So what quadrant are my x and my y's both negative? Well, it's down here in quadrant 3. So let's say I just have this point down here, negative 3/5 and negative 4/5. And we want to find 3 other points that has that same value of 3/5 and 4/5, but it doesn't necessarily mean I'm going to have the same negatives or positives. So if I went straight over here on the unit circle, these points, because of the way the unit circle is, because this is 1 and this is also 1, these points would be the same, but what do we have in quadrant 4? Well, my x values are positive, but the y value is still negative. Now what if I drew a straight up line from here? Well, again, this is the same one here, and we can, if we wanted to, we could prove that the angles are the same. So I know for sure my x value is the same. And if I solve for the y value, I would get 4/5. But up here in quadrant 1, we know they're both positive. So if I take my line and I go over here to my last quadrant, so right there, I know for sure my y values are the same, both positive. If I use this same equation up here is another way to think of it. If I use this equation, I would find that I would get 3/5 for this quadrant, but it would need to be negative because in quadrant 2, my x values are negative. So when it says what are the 3 other points on the circle using symmetry, it's this point, and this point. All right. That's it for task number 1's lesson.